Hello, general biology students. Today we're going to view our next video in our climate change discussion, and that is over changes in our atmosphere, specifically changes to carbon dioxide. And this guy that started all of this off, the guy that is like the father of climate change, is Charles Keeling, this old dude who decided that he wanted to study the atmosphere in Hawaii because scientists get to choose what they study and where they study it, and if you will get to study things in Hawaii, why not? So he's in Hawaii checking the beautiful skies, and he's checking them for carbon dioxide, and he notices some things. Whoa, I'm missing. Oh, there it is. One of the things that he's noticed is that he's measuring the carbon dioxide. He's finding parts per million. How many little tiny carbon dioxide particles are there in the millions of air atoms that we have? And he finds that in the summer, the carbon dioxide decreases, and the winter, the carbon dioxide increases. And that's because in the summer, there are a lot more plants that are active, and plants do photosynthesis. And when they're doing photosynthesis, they pull carbon dioxide out of the atmosphere to make glucose. So in the summer, we've got all these plants pulling carbon dioxide out of the atmosphere, out of the atmosphere, out of the atmosphere. It's great. But in the winter, they hibernate, they drop their leaves, they don't do photosynthesis. A lot of plants stop doing photosynthesis, but the rest of us, we're still doing respiration. The plants are even doing respiration. So we're breathing that carbon dioxide back into the atmosphere. All of the animals on the earth are doing this. So carbon dioxide increases. And then the next summer, the spring, the plants wake up, they start doing photosynthesis, they take carbon dioxide out, and then the next winter, carbon dioxide increases because we're all still doing respiration. Well, that's what's happening from year to year. But if we start zooming out, we can see that in the summer, we're making more carbon dioxide than the plants are taking away in the winter. So he started this in 1958, and we've been carrying it on till today. And we see that pretty much every year, almost every single year, the end of the winter is higher carbon dioxide than the last winter. So when we go up a little bit higher, and then we come down, and then we go up, we go a little bit higher, and then we come down. So that's tricky. But scientists were like, well, has it always been this way? Is this just a normal thing? Is this not a problem? Is this natural? What's going on here? Well, they needed to go back further. Now, they can't actually go back in time and start recording, so they had to find places where you could get old samples of the atmosphere. And it seems crazy, but they found it. Here, they found it in ice. The Antarctic is full of ice, and if the ice gets formed and it makes a little bubble, that means that atmosphere is trapped in the ice until that ice melts. So by digging down, deeper into the ice, we can get samples of atmosphere from farther back in time. And they were able to get samples from the atmosphere as far back as 800,000 years ago. And there is a natural cycle of rise and fall. About every 100,000 years or so, it peaks, drops, rises and drops, and 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 rises and drops. So there is a natural cycle. And in those 800,000 years, it ranged from about maybe 170 parts per million to 300 parts per million. Go up to 300 or about, and then down, and then up, and then down, and then up, and then down. But this business has not happened in our geologic understanding of carbon dioxide. So what is happening to our atmosphere right now is different. It's not part of the natural cycle. It's not part of something that has happened in the last 800,000 years. Today, our CO2 count in the atmosphere, at least from December 2021, the average in December 2021 was 416. That's a lot higher than the natural 300 peak from the prior years. So what's happening? Well, it started going up like that in the 1800s. And that's when we had the Industrial Revolution, where we started to figure out all these technologies that allow us to burn fossil fuels with combustion in order to make a lot of energy so that we could run machines and we could run locomotives. And then we figured out how to do that to run cars. And we do that to run power plants, certain power plants. And so we're getting a lot of energy by burning these fossil fuels, which has allowed humans to do a lot of incredible things. But it's a new way to get carbon dioxide into the atmosphere. And so our atmospheric carbon dioxide is changing and has been changing in a way that it has not been natural. It's not a normal part of the cycle. It's a new way to get carbon dioxide into the atmosphere. So let's review these notes. Charles Keeling was a scientist who studied the atmosphere from Hawaii, and he started in 1958. He discovered that CO2 decreases in the summer because more plants are doing photosynthesis to make glucose, which takes carbon dioxide out of the air. He discovered that CO2 increases in the winter. That's wrong. Because many of the plants stop doing photosynthesis, but the rest of us, we all continue to do respiration, putting carbon dioxide back into the air. He noticed that year after year, carbon dioxide in the atmosphere slightly increases, and he started measuring in 1958, and the levels were at 320, and today they're above 410. And then they gathered samples, scientists gathered samples from ice, from atmospheres trapped in ice from the past all the way back to 800,000 years ago, and carbon dioxide for 800,000 years would cycle between 175 and 300. It never got anywhere close to 400. And so in the 1800s, when humans started burning fossil fuels for the Industrial Revolution to get energy, our carbon dioxide levels started rising. And now that's how explains how they can get to be 410 today. I hope this helps. Struggle well.